Welcome to Quiz Review for Unit 4. This is from lessons 1 to 5. So after we go through this review, I suggest you look in those lessons for anything that we do in this video that you feel like you need more help on. It will be tomorrow during class. This will be a quiz on forms. Yes, it is multiple choice. No, you can't get away with not doing work. There will be commonly wrong answers on there, so definitely doing your work will help eliminate that. Also, tomorrow I will not be in school, so I'm not going to start the class meeting. Right when class begins, the quiz will post. You can work on it individually. I'm going to trust that that is exactly how you're doing it individually. I really need to know where you're at and be able to assess you properly. There are things to memorize. And yes, a lot of what we do is application, but you can't apply anything if you don't have certain things memorized. First, you need to know how to convert back and forth between log and exponential form, from one direction to the other and back again. This should be done fluently. This is from lesson 1. It is also the prequel lesson that we did, so either one of those videos would be helpful if you need it. How to find domain algebraically. Yes, you can look at a graph, but there is a way to do it algebraically so that you don't need to rely on the graph, especially if domain is not your strong point. This is from lesson 2. When to use a log. Lesson 3. I will go over this, of course, but not only when to use the log, but what to do first, like how to prep it. What is E and what the natural log of E is equal to. Lesson 4. And then finally, the two formulas that we learned in lesson 5, the compounding rates formulas, when to use them. And then that will also tie back into 3 and 4, when to use a log or a natural logarithm. So here we go. So 3 to the power of x is an exponential. If I wanted to find the inverse, I would switch my x and y and solve for y. The problem is I don't know how to solve for y. So I am going to rewrite this. So my answer's on the right. That's just, you know by now. That's how I like to do it. So 3y equals x. So we learned to convert the form. It would be log base 3 of x equals y. So these are inverses, all right? They're inverses, which means their x and y are reversed. So what I've done here is put these both in my y equals. They correspond to the same color I wrote the equation with. So the blue is my 3 to the power of x, and my red is the inverse, log base 3 of x. Now I would like to point out, as in before, the calculator does not draw the line down on the log. So you are responsible for doing that the best you can. Let me do the best I can with this. Okay, so these are inverses. They clearly are reflected over a line, and you really should know what that line is. So that is this black line here. It kind of looks like a mirror image, correct? And you should know that that is the line y equals x. That is always the line of reflection on inverses, okay? So why do we use the log? The log is used when we have to find an inverse and we have to solve for y or x, whatever, when it's the exponent, okay? So in order to do this well, you need to be able to convert between the two forms. So converting forms, it's really kind of just memorizing what goes where. I prefer to have my answer on the right. I don't know. It's just the way I do it. The last one, the answer is not on the right, so I will rewrite it. So the first one is saying 2 to the power of what gives me 8? Well, I don't know. Could it be 3? Maybe. Sometimes you know what they are, right? But often you won't, especially when they're decimals. So I'm going to convert log base 2 of 8 equals x. From here, you can put that in your calculator. Math Alpha Math is the shortcut to change your log base. And you should get 3. 2 to the power of 3 is equal to 8. So on number 2, you might already know what it is, but maybe not. 3 to the power of what gives me 1/9? So if I don't know, I'm going to switch it to log form. So log base 3 of 1/9 equals x. And then you're going to put that whole thing in your calculator and you're going to find out that it's -2. Now, on number 3, this one, we're dealing with decimals here. I also don't like my answer being on the left side. Some people just can convert, it doesn't matter. I like to be as consistent as possible. So 0.5 to the x equals 0.0625. And again, you're not changing anything whatsoever. You're just making it more visually appealing to convert it. So I have log base 0.5 of 0.0625. And you can put that whole thing in your calculator looking crazy like that. And you should get 4, which is a pretty nice number for that crazy problem. You must also be able to go the other way, from log form to exponential. So something like this where the x is where it's located, you can't put it in the calculator. So I'm going to convert it to exponential form. So 2 to the power of 4 equals x. Okay, well that makes more sense, right? 2 to the power of 4 is 16. Same thing for number 2. So I have 7 to the power of -2 equals x. So that becomes 1 over 7 squared, which is 1 over 49. Okay. So this is where we're at. We're now solving for the x. So the rule is your base has to be alone. Okay, so I'm going to divide both sides by 60. And I have 3 to the x equals 4. I'm solving for x, it's an exponent. So from here, I'm going to put it in log form. And then from there, I just put that in my calculator, log base 3 of 4, and I get 1.262, rounded, of course, and that's the gist of it. I suggest you go back to lesson 3 and look at similar problems. Some of them get a little bit more complicated and you should practice those. For example, on questions 2 and 3 from the homework, you should take a good look at those. Okay, so we move on to E and the natural log. So if we have E in a problem, and we convert it to log form, you end up with log base E. Meaning, say we have e to the power of 0.2x, right? You want to convert it to log form, you get log base E of, let's say, y equals 0.2x, right? And then whatever. So what we learned in the lesson, that log base E is exactly the same as the natural log, okay? So there are times when it's easier to use the natural log instead of log base E. Now remember, when you use the natural log, you're not changing formats like we just did here. You are just inserting it into the equation, and whatever you do to one side, you have to do to the other. Why? Why would we even bother using the natural log? Well, the reason for that is if I have log base e of e, that's equal to 1. So if I take the natural log of e, that's equal to 1 without doing any converting or moving anything around. I can just change it to the natural log of e, which makes life easier when we have a 1. So before I do any problems with the natural log of e, I'm going to just combine that with lesson 5 because the e pops up in parts of lesson 5. So lesson 5, you have 2 equations that you have to memorize. So you have these 2 equations. They have to be memorized. They will not be given to you, all right? We learn them in the same lesson. So when do you use which ones? So you are looking for the following words for the equation on the left. So compounded monthly, that's like very common. Quarterly. Weekly. Daily. You might see other things, but any amount of time, compounded any amount of time, is that one. And then APERT is compounded continuously. All right. Okay, for now, for the sake of time and getting this done, I'm not going to write the whole word problem. Here's the gist of it. We're investing $1,000 compounded continuously. The rate is 3.7%, and I want to know how much will be in the account after 10 years. So we're going to use APERT because it's compounded continuously. My principal is $1,000 E. My rate is 0.037 and 10 years. So you're going to plug that in your calculator and get a nice number. So you should have gotten $1,447.73. Now, where it really gets tricky is when they say something like, how long will it take for your investment to reach $1,500? Or how long will it take your investment to double, etc. So that's what we're going to do right now. So let's double the investment, okay? So double the investment would be $2,000. We want to know how long that's going to take using the same equation, compounded continuously. We don't know the t now. We know it's going to take more than 10 years because when we did 10 years, we got 1,400, right? So from here, I'm going to divide both sides by 1,000. 2 equals e to the 0.037t. I'm going to move my 2 to the right side. And now I'm going to do the natural log. You can convert to log form from here, but it's easier to do the natural log, which means I'm just going to put the natural log there. But whatever I do to one side, I must do to the other. So I have the natural log of e to the power of 0.37t equals the natural log of 2. The power rule says I can put that down in front. So now I have 0.037t natural log of e equals the natural log of 2. Well, the natural log of e is 1, which is the whole point in doing that. So if 0.037t equals the natural log of 2, divide by t's coefficient, and you get whatever that is in your calculator. So rounding to the nearest tenth, I'm getting 18.7 years. Okay, last problem, and then if you're feeling like you need more practice, you need to go back to your notes. Like my word problem here, can you decipher it? We're investing $200 at a 4.3% interest rate. It's compounded monthly. I want to know how long till it reaches $430, so more than doubles. Compounded monthly tells me I need the other formula. it helps to write it down every time. My principal amount is 200. My rate is 0.043. My N is my 12. That is the part that is new. Now, from here, I want to know when it's going to be $430. So I'm actually going to put that here. And I'm going to start getting my base alone. This whole thing right here is my base because it's all in the parenthesis. So I'm going to divide both sides by 200 first. And it does give me some sort of simpler fraction or decimal that's not like crazy. So 2.15. And then I am going to simplify. If it's not too like crazy with long decimal, I'm going to simplify that base. And actually, when I simplify it, I get 1.003583333. That's like too long and it's crazy, and I don't want to round it because it could make it a little less accurate. So I am going to actually leave this as is. So 1 plus 0.043 over 12 equals 12t. Now, I'm not using a natural log here because I don't have an e. But I am going to use a log because I still have to use a regular log to solve for t. I'm going to move my 2.15 to the right. And I'm just going to put in log form. So I have log and then that crazy base. 1 plus 0.043 over 12 of 215 equals 12t. I now want to divide both sides by 12. Now that is looking kind of crazy, so you want to be careful with how you put it in your calculator. So this is what you want to put in, okay? You want to do a giant fraction. When you change your log base, it does let you type all that stuff in there. Just remember you have to put in another fraction. And the calculator automatically puts parentheses around what is connected to the log, so that's automatic. And then when you do that, you get 17.833. So it will take almost 18 years, 17.83 years for the investment to grow to 430 degrees. All right, that's all, folks. I'm not saying everything in the review is exactly what's going to be on the quiz. It's definitely meant to help you, but you do have to do a little bit on your own. Do some practicing on your own because I just did everything for you. So do some practicing on your own. Go to the homework questions, cover up the answers, do them again. And then send me a message if you have any questions, and good luck tomorrow. Bye.